Okay, the last section in this unit is piecewise functions. Piecewise functions aren't too weird. Piecewise just means that you have two pieces or more of a graph. So you might have two different equations or three different equations all in the same graph. So if you look at number 1 here, if you notice, we've got a piecewise function because we're taking a piece of this first one and a piece of this second equation. So we just graph them normal. That first one is y equals mx plus b, if you remember that. So it's a line, m being the slope, and b being the y-intercept. So that one's super easy to graph. So you graph it normal. This one here is a quadratic, so you got to go back to the vertex form from Unit 5. You can also use the parent tables we've been learning in this unit. You have to use -2 through 2. And when you square those, it becomes 4, 1, 0, 1, 4. And then if you have any multipliers, you'd have a times a there, but we don't on this problem. And then that -4 is after the squared, so it'd be moving down 4. So it's up to you whichever way you like to graph it, but you're going to graph those two things. And then after you have those on your graphs, it might look like a U shape and then a line. I'll do a different color here, like this. Once you have those on your graph, this piece right here, the inequality, tells you what to keep, what piece you want. So x less than 0 means you want the numbers smaller than 0. That's what this symbol means. So smaller than 0, 0 is right here, smaller is the left side. So on my line, I want all of this. And then if you take a look, the inequality symbol right there is an open dot right at the 0. On the next one, if you have x is greater than 0, we want the right side. So that's for our U shape, okay, because it's right next to it. So on our U shape, we look at 0, which is down here, and we only keep the right side. So the red is our final graph. And then that one has a line underneath, if you notice right there. That line means a solid dot, because you can include that point. So that's it, pretty much. So again, if you see this symbol, it's an open dot. This symbol, it's a filled in dot, right at the end point there. And then if an open and a closed happen at the same exact point, you don't just write a bullseye, you actually just fill it all in. So it's just one single solid point. So let's try some of the homework. Homework problem number 1 is pretty easy. If you look, go ahead and pull that up, pause the video if you need to. We have g of x equals, that curly bracket, x plus 1, -2x minus 3, x is less than -4, and x is greater than or equal to -4. So when we graph it, both of these are actually going to be straight lines. So for that first one, we're going to start at +1 and have a slope up of 1. And if you had pretty graph paper, I'd expect you to do this nice and accurate. The second equation starts at -3 and has a -2 slope. So when you go to the right one, you go down 2. So you always go to the right one and then down whatever your slope is. So it's like this. And let's see, up over 1 up to, yeah, so something like this. That should connect. And then let's look at the inequalities. So that first one, the green one, let's keep that green here. So this was all green. We're going to look at the numbers smaller than -4. So -4 was right, let's see, 1, 2, 3, 4 most likely. I mean, your graph will be a lot prettier and more accurate. But -4 is right here. So looking at this green line, I put an open dot there, and I only keep the left side. That means you get to erase anything green on the right side of that line. It's no longer there. Okay. The bottom one, the blue line, this is why I like to color coordinate. Blue line, we look at that same -4, and we're keeping the greater numbers, so to the right. And it has a solid point there because of the line underneath. So we put a solid point here and keep the right side. And we can erase the left side. And that's your graph. Super duper easy. We're going to try a little bit of a harder one. Problem number 15 on your homework. Again, not crazy, but pull that up and go ahead and make sure you have that written down on your homework. And I'll write it down here. This one has a square root function and an absolute value function. So the first one, let's do that in red. So when we go to our graph, we are going to start +3. We switch it to -3 because it's in with the x. So we go to 1, 2, 3 and put a point there. And then for our table for that, we're going to do radical x. So 0, 1, 4, 9. Remember, radicals don't get negatives. And is there any multiplier here? Doesn't look like there's a number in front. So these are just the two numbers we use. So 0, 0, 1, 1, 1, 2, 3, 4, 2. And 9, where's 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Like that. Okay, the second one, let's do green. So x is -3. We're going to change that to +3 because it's in with the x, so it switches signs. So it's right there. Notice there's no number at the end, so we didn't go up and down. Our table for this one is absolute value x. So we have -2 through 2. Make those positive. And this one also doesn't have a multiplier, so that's it. So we go -2 up 2, -1 up 1, 0, 0, right 1 up 1, right 2 up 2. So our graph is going to look like this. And then I'm not sure if those right points connect. Actually, they might. Let's see. They totally do. Okay, those intersect. So now we're going to look and see which parts we keep. So on the first one, we want the numbers less than 1. So we go to 1. On the red graph, we want the numbers to the left of 1. So I'm going to put an open circle right here and keep this part and erase the red graph on the right. Not the green one, just the red. Now look at the green one. We want greater than or equal to 1. So we're going to keep the right side of 1. Remember, keep those arrows there if they have them. And we're going to put a solid point there. We have an open and a closed dot, so I'm just going to go ahead and just make that one single point. You don't have to make that so big. You can make it smaller if you want. And that's it. Super duper easy. Go ahead and try the homework for that, and when you're ready, you can take the quiz.